are going to do our final project, which technically uses all the tools we so far learned. Create API with Express Node.js, create a blog app with the Next.js app, something that Google can index, and we can just see on a homepage bunch of blog posts we created, enter each one, read it, and then the dashboard, it's a private app where you have to sign up, create an account, then sign in with email and password, then see all your posts you created, create new posts, edit the ones you already have by making requests to our API server. Basically everything we already done. Just we added a bunch of more details in to make it a nicer, more advanced code base, more useful, and so on. Very, very, very big disclaimer. I'm gonna go through all of these apps that I made, the entire code base, and I'm gonna explain every single thing inside. What I don't expect you to do is understand everything right away, to recreate it right away. That's not going to happen. You don't need to do that. It takes some time for you to scan through the code base to try to recreate some parts of the code base. You don't need to create everything right away. Just try to recreate one page, see how I've done it, copy paste it. The main point is you can copy paste everything and try to run it on your own PC. The whole point is for you to understand over time, not right away, but to try to understand what that thing is and basically just how it works in general. Over time, you'll learn how to implement it yourself once it goes through your hands many times. And essentially then, once you're able to recreate the project yourself, you can consider yourself like an official with all of these tools and everything we'll build. You'll have definitely like 5 times more knowledge than I even had when I applied for my first junior job. So I'm literally teaching you very, very important fundamentals. And once you are able to recreate this entire project yourself in any way, technically, you can easily think of yourself like having initial skills to create any other project. It's just different use case, So here we are creating a blog. You create some stuff in the database. Then you read some stuff from the database, you display it on the screen through React app, you render it on the screen. Basically, that's it. Like if you want to create a contact app, you can create an app where you create a bunch of contacts, like in your contacts app. You read a bunch of contacts, create new ones, show them on the screen, log in, log out from the app. It's all the same kind of things, just different use cases. So once you learn all of these that I'm showing you here, even if it takes you like a month and a half, like 3 months to be able to familiarize yourself with this, which I doubt because it's basically all the fundamentals we already went through in the tutorial, just a little bit more other functionalities here and there that I'm going to explain how it works. And again, you don't need to memorize this code base. Just don't even try to memorize stuff. Just try to listen and try to understand what each of these code base parts are doing, what their job is, and basically later on you can copy paste, try to recreate it, whatnot, until you are like recreated it so many times that you're like, oh man, I know this, like I did it a million times. So basically that's the process of learning this. Like that's what it is. You just need to put some time and effort into it. And the important part is this is all the code base. Part of the code base I've learned over a few years. I gathered together, and this is all for free for you to use. Many people wouldn't even consider giving you their own code base or their own code to use. So technically, this is a bunch of very useful code, at least for my experience, so you can kick off your own projects, create a bunch of new stuff. You don't need to figure out how to structure your code base yourself. It's all here. You just need to learn to use what I already written here, and that's it. Create new different projects, different use cases using the same code base. It's pretty much it. And then you can apply for your first junior job and become a web developer officially. Anyways, let's get into it. Tutorials, I completely forgot that I didn't connect this screen share to my AirPods, so my own Mac built-in microphone is picking up my voice, so it sounds so deep, like from a dungeon. But I'm too lazy to recreate all that content now using my AirPods. Anyways, it is what it is. I barely even got some motivation to sit down and create all of these videos on top of text tutorials already written. So, deal with it. Anyways, so the projects folder has a block folder inside, and then it has our API, then it has our React app, and then our Next.js app. Basically everything familiar we already done, just a bit of different things here and there. I'm gonna show you. So by the way, Yarn and NPM are kind of doing same things, just Yarn is a bit cleaner command. So NPM in the scripts, if you put, so some common script commands are start, test. So you can write NPM, for example, NPM test, NPM start. But if it's a custom command like dev start, you need to put NPM run. You have to say npm run dev start, and it's really annoying. So with the yarn command, you can just say yarn dev start. You don't need to put run in front of it and so on. That's one of the benefits. So instead of using npm, instead of saying npm install, you can just say yarn, and it will install all your dependencies for your project, for example. So that's why I'm using yarn, but it's basically for the same purpose. So here I have one terminal, but I split it in two terminals. And this terminal here, I entered my API folder. I started my API. Mongo has connected, listening on port 5000. And here in this other one, I started my dashboard, a React app. So I'm gonna show you actually the output of everything we'll do. So here you can enter full name, email, password. I'm not gonna do that. Oh, I can, whatever. So John Doe, full name, and then I can say john3@doe.com, and then password. So if I do this, and you'll see in the API, if the email already exists, the API will return an error saying this email already exists, because all accounts have to have a unique email address. So because it already exists, we'll use a different email, but this email also exists. So which one? Okay, this one worked. So now the user, we can log in with a John4, is it 4? At the Gmail, no, at doe.com. But look at this, I'm gonna add this. So also for the sign-in route in our API, if the email doesn't exist, it will say no account, basically no account found. If the password is incorrect, it's gonna say password is incorrect as well. Only if the email exists and password is correct, only then it will allow us to sign in to our app. And by the way, here, if we are logged in, you cannot go to sign in route any longer. It will redirect you to the post page. And also you cannot go to sign up page, right? So this is gonna get handled in our React app. So only if you're logged in, you can visit this /posts route, and you can no longer visit the other ones. But if you're logged out, so if I log out, I can only visit sign in and sign up pages, but I cannot go to post page because I'm not logged in. So it will redirect me back to this sign in page. This is very important. We'll see how we handle it in the code. So if I sign in again, basically we have 3 pages. One is here you can have some nice thing like changing this to a dark theme. It's a little nice feature. Then you have this like clicking and get a drop down with like a sign out button. We click this, it signs us out and redirects us back to the sign in page. Here we have a home page. Basically, we fetch the posts that this account specifically created in the database and shows us all the posts. Then we can click on each one and we go to this route /post/ID. So if you go to this route in a React, we take the ID from the URL and fetch this specific ID from this specific post with this ID, from the API. And then essentially we have 2 inputs, title and body. So we insert in these 2 fields what this post has for the title and body text. So we can technically update it. And once you click save, we update this post into the database based on these new values. And if you go back to the home page, here is our new updated post title. If you want to create a new post, you click this button. It will redirect you to the /post/new URL. And in this is another page in React where you can put some title, some body, text, whatever, and it will create a new post. And new post is created, and it redirects us back to /post/id for this new post. You can handle this any way you want. This is how I handle it, just for the principle of building this app. It doesn't matter. You can do whatever we want. So see, now we have two posts. If I go to ASD, we go to /post/id, we see this post, we can edit it if you want to, that's it. This is our technical React app, right? So let me show you. And mind you, in this React app, once you are logged in, you can only see posts that user created. But if you go to the other app, the blog app, which is an Next.js app, here, sorry, so here in the Next.js app, I use npm instead of yarn, just because of some buggy reasons with the npm, with the yarn. It doesn't matter. So I start the Next.js app, and then in Next.js app, difference is we can see all the blog posts because it's a public app. There's no login. Technically, all the posts we can see publicly in the database. Our API returns, and we can see it in the screen. So once the app starts running, we can see it in action. So now this is our Next.js app. There's some. Oh, good. There's some issue. So it says the title. So if you go to the blog, I know, because I created a title. I created a post in our database which doesn't have the same structure as all other posts. So if I go to the components pages, and we are gonna go through all of this. So I'm gonna say here post.title or post.data title. So this is how you solve bugs. You see that you didn't cover a use case properly. You see what the issue is and you fix it. This is a good lesson. So now I updated my code. Let's see if this fixes a bug. Waiting for our code to recompile so we can see it in the browser. Let's see if it's fixed now. I think that was the bug. Oh yeah, it is. So here our app also have this dark theme like theme switch. We're gonna go through. It's not that hard. So here we have a list of all the posts in our database. If I click on one, and it's on our root domain, basically index.js in Next.js app. We just fetch all the blog posts, and we already done this even in the tutorial. In this case, we are just not fetching dummy posts, we are fetching posts through our custom API, posts that we created from our database. That's the only difference. I click on a single post, and it returns me, goes to / whatever post ID, and in this page, in Next.js, I fetch the post, and we just display the title in React and whatever the body text is for this post. That's pretty much it. We go to the home page, that's it. And this app, again, can be indexable by Google search engines, where React app cannot. So that's why that's publicly facing public, something that people outside should search for, read, and find on Google. That's why we need to make this part in Next.js, but React, the dashboard itself, should be in React because it's much easier to build the React apps than Next.js apps. And it's a private dashboard. Nobody needs to find it on Google. People know exactly URL to go to log into our app. So basically, that's pretty much the difference. This once we start with the lessons, I'm just gonna run through each of these code bases, so explain what's happening inside each one. And once you get to recreating each code base and trying to recreate it, whatnot, you can go back to this video, see how I explained it, and then you can just try it out for yourself. So I'm just gonna run through each one and explain what's going on. So the API is, and I'm gonna go in the GitHub itself here. So there's some of the folders new here, like editor config, JS, beautify, blah, blah, blah. So these are basically just for our code editor to have some consistent styling of the code. You can just copy paste those. Git ignore as well. You just don't need to worry about these now at all. The package JSON, we installed Express. This is what we use for our server. Then to create our Node.js Express server. Then AGV is a library used for validating the incoming JSON data for creating stuff in our server, like validating the schema. Did you properly create the schema that before you sent it to the server and so on? And the rest of the stuff is like this is used for encrypting password. We should never store a raw password in our database, but encrypted version of the password. Then compression, cores, helmet, these are all like plugins for the Express to do some stuff, whatever. MongoDB, this is the used library for connecting to MongoDB, as you already know. And JSON Web Token, you're going to see this part. Once somebody officially logs in, we create this token, just like a string, send them back in a response to the browser app, and then browser app includes that string with every next request it makes. So then we read this string from the headers of their request, and if we successfully decode this token that we previously sent them, that means that we sent the token, and this token is validating them as being authenticated to talk to our server. This is how the authentication happens with the server. So I'm going to explain it, but it's using this JSON Web Token. And then basically these are testing libraries, Mocha and Chai HTTP, blah, blah, blah. You don't need to know any of this setup. I already made all of this code. You just need to understand what happens there and basically how to further test your own code. You'll just learn it over time. You don't need to know everything in advance right now. So in the source folder, we have a couple of folders here. Index.js, this is our main app. Then config, controllers, database, errors, middleware, models, utils, validation. So in the tutorials, we crammed everything in one big file, right? Usually you don't do that, so you need to keep your code base clean. That's why I put all of these functionalities in different folders. But I'm going to start from index.js. I'm going to start actually from config. So in config folder in index.js, remember how config file, we put it inside like an object and then a module export this object. There's I find a much better way to also do this, much more useful down the line. So I created a class named config, and inside I have a bunch of default values. And then, and I'm going to explain this, you can store your private variables, like links to your database and so on, in .env file, which you would place directly here. So you would create a file called .env or .env.test, and inside of those, you would basically write stuff like this. So just let me. So it's basically this .env, .dev, and .env.test, for example, and we should never upload these files to the anywhere. So it's our own secret variable, secret links nobody can see. So basically, this is how you do it, like db underscore mongo underscore uri equals whatever our private link is to our database name, blah, blah, blah. So then so we put those files here, and you see I did not upload them. This git ignore prevents me from uploading those files accidentally. So if I go to source and config, we use this .env library, and we say if the node environment is test, then upload .env.test, all the variables from there, insert them into basically our coding environment. Otherwise, use all the variables from .env.dev. In .env.test is my actual username and password, like inside of the database link. So I'm not going to show you that, but you should not show that as well to anybody else. So basically what I'm just saying is if you're running tests, and I'm going to show you this line of code, that's what it does, then load all the variables from .env.test, otherwise load the variables from .env.dev. And basically this is the lines of code you just need to do for that to happen. And then in your config dynamically, we will get all these variables. So config db mongo URI and URL is, so this is how you access this is called like process environment variables. So you don't need to understand it too much. This is basically what I just explained. This is variables hidden in this code, in these files, and this is how you access them in your system. Process.env. Whatever the variable name is, or use the default one that I set here, some of default values. And it's a class, so basically we export the instance of this class. So anytime we want to use the config, we will just import the config from this file and then access the config, like config.config.db.mongo.uri to get the actual variable for our server. So this is how you do it in like more professional environments. It's more dynamic, more reusable, useful, and so on. So here is our basic, in a way, basic file for creating a Node.js server. Express, it's a little bit different, like don't get scared. So all the logic for connecting to our MongoDB, I stored in a /database/mongo file. And that's why we just import it here. And in one line of code, if it's not, if we are not testing our code base at the moment, we'll get to that. Then try to connect to MongoDB. And then these are just plugins we already went through. And then each route is in /controllers/root controller, account controller, auth controller, post controller. So those are just separate JavaScript files where we define routes for each of these endpoints, /account, /auth, /posts, and so on. So here we just register all the routes in our Express app. We don't cram all of that logic in one big file. So those are our controllers. This is our database, blah, blah, blah. And then there's a middleware that you can use. So when you say app use some middleware, basically, again, same kind of logic like for the regular routes. But if you globally register it like this, but not like specifically for a route, then this function, this logic will be called for all the routes. And auth middleware, which we are gonna see, what it does is checks whether you send that JSON token that you can include in headers to authenticate yourself. Did you send it in the headers? If you did, we attach to that request the entire account object, like who are you, who is making the request. So inside of that logic down the road, like that more nested logic for our API endpoints for accounts or posts, we can see whether you're logged in or not, technically whether you're authenticated or not, and either reject your request or not. So this logic just checks whether you sent some authentication details and attach that user to the request so we can check it later down the road. And basically these are some other stuff. Also, so there's a specific error handler that you can make that anytime any of these routes somewhere, if they throw an error, all that error bubbles up to this one method here, which can so all the errors that can be thrown in the API by any API endpoints, they all bubble up and come to this one function, so we can handle all errors in our API that are thrown in our API in one single place. So we can send like a consistent error message back as a response to the browser. And then some server errors. This is just logic. You can copy paste all of this, like whatever. You don't need to understand this too much right now. And again, remember we said app.listen, our Express app right here. This is just additional logic. You can do, basically does the same thing. So don't try to understand it too much. We create a server, we listen to a server. It would be basically the same as if you listen to our app here. Don't break your brain too much. And in config, remember this is a class. We type get config.port to get our port from our config. It's a bit more advanced than what we've done in tutorials, but over time, it's all gonna fit into place and you're gonna understand what's happening. In the database and then Mongo folder, we have index.js. And basically here, we just created a class, Mongo. And again, classes are very useful because they can encapsulate a bunch of methods and functionality under one like bucket, under one like scope. So it gives us a bunch of very easy way to organize some data. So that's why I put it in the class Mongo. And again, you don't need to just try to understand what's happening here, what methods I created, what it does, and you'll see it later in the code how it actually works. So basically here I created one method inside called connect, which actually, see, this is our variable from a config, our database URL. And we already, you remember this method, we already created a new promise. We just did it for a tutorial in a bit different way. But now I packaged it in this class, so it's a bit more, looks a bit nicer. That's pretty much it. I just repackaged it in a different way. So here, if it's successfully connected, we, in this DB, which is a property of this class, we store the DB, we store basic, all that kind of stuff, and then we return blah 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 blah. And if you want to get a collection, we say mongo.collection and then put a collection name, and it says this db.collection. And again, remember this line of code from a tutorial. So this is just a bit more nicely packaged than what we've done in a tutorial, but it's same principle, same kind of thing, just in a different file, a bit differently organized, nothing special there. So if you go to the source, so now all of our controllers, it's basically defining all our routes, how things are. So first, a root controller, it's just basically doing these health endpoints. We're just saying, where, again, remember this, express.router, and here we're just saying route, like a root route, just return like, oh, it's a successful response. And then a health endpoint is basically /health get. It's also just returning 200. So these are usually useful when we have monitoring services that are just pinging our server, like basically sending a get request here or here, just to see if our server is still alive, if it didn't crash overnight or something and nobody got alerted. So basically that's why you usually create these ones, and these endpoints that are also always public, they always return whatever OK response 200 code, just so those monitoring services know that the server is up and running. So usually those are those routes. And by the way, again, in the root controller, we can just send JSON. Remember, we just send like an object and response and then OK message inside. Why I've done this, like API response? So usually that's why these models come in handy. And model is just a class. It's just a class that does something. So for me, not to write here an object with a response property and then the value being OK and doing this the same way here, I've created this class called API response with a bunch of these methods. So to them, I just pass the value and then they nicely package a response object, whatever it has inside, and that's what it returns in like a one centralized way. So if I want to change how the JSON response is returned to the server, I'm not gonna find all the places in the code where I wrote object response OK and then change a response from response to data, the property name. I'm not gonna do that in like 50 places in the here, because I always use this class and this method that actually returns that object. I just need to edit it in that one place, so it's edited in the entire code base. So these are just small useful practices. You can always follow the code. So if you see that I exported it from this, you can go into this folder, see what I've done, and this is the logic I explained, just so you can edit in one single place. So here, and then API response model. So it's basically a class. And by the way, class has these static methods. So you don't need to create an instance of the class to call these methods. You can just directly use this class and type this this method, so it just does something. So basically here we have meta, pagination, and response, object properties of this class, and basically we have a bunch of different classes. So if I return from a single result, whatever the value is, for example, it's OK, what I return is a new API response class with this response being just OK. So I know this sounds more confusing than it is, but what it gives us is basically, it will give us an object being like this, a response, and the value is OK, and that's pretty much it. And maybe some meta detail like code inside is 200, whatever. So this is going to be the response we will receive in the front end from this class right here. I'm not going to explain it too much. This is the code I learned over time to make stuff a lot more cleaner, reusable, a better code base. You can take your time to try to understand this, track code back, like, okay, if this line of code, it returns new API response, so it creates a new instance of this actual class, and then I get these properties, meta pagination response. You can console log once you make a request what this function returns, so you understand what's happening and so on. That's now on you. I just explained you the logic behind all of this. You don't need to, I know your head will hurt right now, but over time you'll see the logic and why I've done it. Also, I just explained it, but you'll realize from practice why this is very useful instead of hard coding the way we return JSON responses for every single endpoint. Um, Now I'm gonna explain the middleware. So the middleware, when you define a route, you define a path, and then the second argument is a function with the request and response arguments. Request is an incoming request, response is an object you can call methods on, like status and whatever, to return a response back. So middleware take exact those arguments, but there's also the third argument called next. So basically just the same function, request, response, and next, and it just does some stuff. And if it calls next, the request moves on to the actual controller function that processes your request. Otherwise, if the next if the error, like new error or whatever error, is thrown within the next as argument, then that's where the request stops, and then the error gets handled, and then the user gets like a error response. The request will not move on from this middleware. So middleware is just useful so you don't repeat the code in all the endpoints. You just write it in one function here and you attach me. So basically when you define a route, you can define multiple functions, like array of functions, this function like this, and then comma, another function, comma, another function. You can define as many functions as you want for each route. And the last function usually is the one that actually sends the response back. But these middlewares before that last function, they all have also request, response, and next, but they just do some stuff before we hit that last function that will actually process your request and return a response back. So usually this is useful for like authentication middleware. We check if your request headers, so as you have like a request body where you send some data, or request method, or request URL, also you have a request headers. It's just an object where inside headers object you can set some key values. So basically, if the key is API token and you attach the token that you will see later, once you authenticate, we'll send that token to the browser. So if that browser app on this next request attaches that token in this manner into headers, and we find it in this middleware, we'll just try to decrypt it and see if it is the token we sent to the browser using this JSON Web Token method, verify the token if we are the ones who created the token itself. Then we will consider, and the token inside has some data, we'll just attach the data to the request and move on to actually process the request itself. Basically that's it for the authentication. And in the same way, I also explained we have authentication. So auth middleware just checks whether the token is in the headers. We try to decode the token and take the data from the token, the account data, attach it to the request and move on. But authentication middleware checks if there, so this middleware is happening after the auth middleware. So in the API endpoints, which are only gonna work if you are authenticated, those are not like public API endpoints that anybody can use. Those are just authenticated. You have to be authenticated in order to use them. If there is no request.account that we previously attached in auth middleware, then we throw authentication error, and basically you're not gonna move on. The request stops there. You're gonna get like an error 401 saying you're unauthorized to use this endpoint. So basically that's that in middleware. And then we have another middleware called error middleware. And I explained that in the beginning. So this is the middleware. It's basically, this is that function. It's called, we can export this function, and we imported it in index.js with app.use error. So this error handler is a bit different than the other ones. So other ones have request, response, and next. If you also add a fourth argument, so error argument, that means that this single function will be considered the main function to handle all the errors that are thrown in our API. So this is how Express works. And basically, I created different type of classes for different type of errors. So if error name, so based on different error name, I know the status code is 400. If it's the error type is authentication error, I know the code is 401. If it's a permission error, I know it's code 403. So just conditionally, I can set the status properly based on incoming error. And basically, blah, 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 we generate error message based on different things, la, la, la. And then we just send a response back with the state error code status. And then the JSON is, this is how it looks. Basically, meta property, and inside it's an object with the error message and the code of 400, 403 or 401, whatever it is. So this is basically, you'll study this over time and see how it works, and it will all make sense over time. Now it looks like too much information. I know, I'm sure. And then the validation middleware. So this also looks like a bunch of information. You don't need to understand everything all at once. The whole point is this AGV is a library which basically helps us uh, validate incoming JSON data. So if you want to create a post, and you know how in Postman we sent some data to our server, some JSON data along with a request, a blog post we want to save into the database. Here, it's a middleware that takes in the whatever the schema is, and it's basically a middleware. So it returns this function with a request, response, and next. So it's basically just another middleware for our endpoints. It takes the schema we pass. So we define like an object saying the incoming data has to have a data property. It has to be an object and has to have a data property, and data property's value has to be also an object. And inside you have to have a title and a body property, and the value of title and body has to be a string. So basically, we define that schema, which you are gonna see, and then blah blah blah. All this logic doesn't matter. This is the key thing. We await validation. This is basically this function above, which this AGV library here, we call the new AGV. This is how you do it. It gives you an instance of this testing framework, and you just say agv.compile. We pass on the schema, and then we technically get this test function, and we just pass the data, that the JSON data person sent from the browser into this function. And if it throws an error, that means there's an error in your schema, an error with your JSON data that you sent from the browser app. And basically, by it throwing error here, it throws an error here, and by throwing it an error here, we use this try and catch to catch all the errors. But then again, because this is a middleware, in the next function we forward this error that we caught, that this function through here, that this function through here. So it's basically we're just forwarding error from here to here. We are forwarding by throwing the error again. So throw error. So it's gonna throw error here. We are catching the error, and then we are officially saying next and passing the error into the next function, which I explained. Once you do that, that means that error was thrown in one of your middlewares, and the request stops there, and the error gets processed by our error middleware right here. It gets this function, and we see what the status code is. We parse the message. So if the message is, so we have a generate message method, which figures out with a bunch of this code, figures out if it's a validation error and extracts the details of that validation error. So it sends like a nice error message to the front end. So this is all from my experience. I had to figure out how to extract from when AGV library throws an error for the schema, invalid schema, I had to figure out how to extract all the details from their error message and package it nicely. So in the front end, basically in the browser app, we receive like a very nice message. So this is just a bunch of my code I had to write to package the error response nicely for the browser. And this is generate message. So the message we get from this You can console log, figure out all of this, like to see what actually happens line by line. If you want to, feel free. That's basically how you learn to understand this entire code base. And basically that's it. The validation schema, now to go back to that one, this is just a validation middleware, but to go to validation schema, for example, for accounts, I create two schemas for updating an account and creating an account. And this is, again, this is one of those things, like it's a standard for JSON schema. It's called open API or something like that schema. It's a standard how you define a schema that you want to validate. So basically what we are saying that the JSON the browser is sending should be of type object. So it should be an object. And the properties it should have is a data property. And the data property should be a type object, and properties the data has should be full name, email, security. And then the full name should be of type string. Email should also be of type string, but some other validation. And then security is just here, is also of type object. It should have a property, password, and the password should be a string. So basically, and then we say that required properties data, here the required properties password, and here the required properties are email and security. So technically the valid schema would be the JSON that we would send from a browser to create an account would be this data. And then inside you would need email, and then email, and then security, and then this should be an object. And this is just how I define the schema because it makes sense to me. So technically, and then also you can have a full name, but remember that here required properties are only email and security. You don't need to add a full name technically to register an account. But if you add a full name as well, it's fine, but it's an optional thing. So this is a valid schema that this schema would pass, like this would be a valid schema. If I missed email, when we middleware that validates the schema incoming basically JSON data, it would go through this schema and see the email is required, and it would send back error to the browser app saying data email is required. So basically this is it. Like we would validate it in our middleware, pass the schema, pass the data user has given, validate it, the validation would throw an error, that error would bubble up all the way to our error handling middleware. Our error handling middleware here would just extract the message from the error that was thrown, package it nicely for the front end, and then it would just return error response to the front end in just one single file. That's why it's nice that error handling is one single file and not like 15 different files. It would be a mess of a code base if it was like that. Like a class, which is I call it a model for a response object. So we have all the way we package a response back to the browser all in one place. We just pass some values to the method. Same way, I created a class model for accounts and for posts. So basically, if you want to insert a new account into the database, the only thing I need you to pass is the body, which inside has full name, has the data, which inside has a full name, email, password, whatever. And just by calling a new account, additionally to the data you passed, I create a unique ID. I create an underscore ID, which is the required Mongo ID, but also I create my own ID, which is what we are going to use. We are not going to use this required Mongo ID. We are going to use our own, and we are using this library unique user ID, whatever it is. And then basically I add another property to the thing we save in the database, which is API meta, and it's an object, and inside it has a received at, and it provides us with a timestamp, basically in milliseconds, saying exactly when this was inserted into the database. And this is very useful because when we want to query our get all the posts, we can sort them based on when they were created, from top to bottom, or reverse, like get the oldest first or the newest first, and so on. So this is why we need this receive that timestamp. You can write whatever name for this property. This is just how I handled it. And basically this, what you see here, when somebody creates an account, this is how you will see it in the database, like actually. So what they send from the browser is basically just this data with a full name, email, and password. What we additionally in this class add is API meta property, and then it's an object with a property inside receive that, and it's timestamp in milliseconds, like when exactly they created, registered this account. And we'll also add a meta property, which we'll use for posts you're gonna see later. So now if you go back, to our controllers, this is what the models is, and now you are going to see in the controller all logic connecting finally together. So here where we create all the routes, so we are going to say, if you go to /accounts and make a post request, first we are going to call this middleware validate, which we here imported from the middleware folder. So we are gonna pass in the account create schema to it, and this is a middleware. So if this passes, that means the data you sent from the browser is fine, and we can move on to our final method that will actually respond, create everything in the database, blah, blah, blah. So this middleware just checks for that, and then if it's successful, it moves on here. If it fails, it throws an error. It doesn't go here, but our error middleware handles the returning the response to the browser, the error message. So if validation passes, then here what we will do is basically our data is inside the request.body, and the schema is that inside data you have a security. That's how we define it. And inside the security property you have a password property. And what we are going to do is I created a hash password function, creates an irreversible, like a unique string. Here we're using the bcrypt library, and you can follow this in utils folder. Here is the method. So basically, bcrypt.hash, we pass the password that user sent, and some salt rounds, whatever. This is all the library itself, how it does it, and basically we return a hash. So we are never gonna send the exact raw password in our database. We are only gonna hash it. And then save this, and so if the password was new password 1, whatever, only you as a user know that this is your password, but this hashing function returns something like this, whatever, in our database. So if you send a new password 2, the hash will be completely different, right? Just because you change one character. So next time you want to log in, you send a username and password, you need to send exact same password. We hash that password again and check whether the hash in our database is exactly the same, meaning that's exactly what it is. This is your password and you are officially authenticated, and we will let you use our server, right? So this is what hashing basically is. So if you go back to, controllers, accounts, so we hash the password and we only store the hashed version of the password in our database. So somebody doesn't hack our database, steal all the passwords. This way they would steal basically the hashed version of the password, which is not the password itself. They can never reverse the process to get the actual password. So this is why we do that. And then basically we call new account class. We pass the request body. It generates this class with the ID, API meta, with the receive that, passes all the email, full name to the class as well, to the data. And so now we use this. And remember in Mongo, we have these .collection accounts, and we can insert one account into the database. So this is the process where we already went through this in the tutorial. And the response from Mongo is this object, which has property ops, and it's an array. Basically, once you access it like this, it will return us the object we just created in the Mongo, stored back into our variable, whatever. And if you want to return account we just created back as a response to the browser, we can delete the security part in the object because they don't need to. No need to see that, and then we can just return the JSON response back to them. Now, I created another endpoint /account/me, and it's a get endpoint. Oh, before that, I'm gonna explain you. So in auth controller, how you log in. So basically the request body, you just send email and password. So now in the Mongo collection accounts, we can find one. So it returns only one object where the data.email equals to the email you sent. So if this account exists, you move on. If it doesn't exist, we throw a validation error, which will again throw the error. The code doesn't move on here if the error is thrown. And our centralized error handling method, we already mentioned many times, will handle this error and send the error response back to the browser. If the account does exist, we take the password you just sent, and we take the hash that we previously hashed once you created the account initially. So if the hash, and there is a bcrypt compare method, so it takes this password, it takes the password we previously hashed, it compares them. If this, once bcrypt hashes this password you just sent, if the hash is equal to this hash, if it's the same hash, meaning you send the same password now for login as the password you sent initially when you registered your account, then it is a valid password. If it's not a valid password, we send authentication error, password is incorrect. And if everything is good, remember JSON Web Token, this method uses, like, we can have a secret string or something only our server knows, and we sign an object which inside has an account ID and then data and then full name, email inside, whatever we want to pass. And it basically crunches all of this object into like a string like this, like blah, 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 and then dot something and then dot another thing. So basically this is the token we will get that this JSON Web Token library can also decode using the same secret. So this is what we send, this token is what we send back to the browser. And then browser app can then include this token in the headers of each request, each following request, in order to authenticate to use the API endpoints that require authentication. Back once we officially logged in, so you registered your account, you logged in, you got the token, you pass the token in the headers, and if you remember, we have this auth middleware in our app. Like for all the endpoints, this middleware is called, it's here, auth middleware. So before request hitting any of our routes, the auth middleware is called, and in that auth middleware, we check. Again, we are going to go through this. I'm just explaining how request flows through our app, so you understand. So this auth middleware goes to request headers authorization, checks whether the token exists, and the token should be of the format like this: API token underscore token, and then space, and then the actual token that we got from the server. So this should be a format that we expect. So basically, we split the token on this, and the second argument should be the token itself. And then we try to verify with the JSON. They have the method called verify. We pass the token, and the secret we also used for creating the token in the first place. So basically the token is encrypted. So in this way, this method checks whether we are the server who actually gave them the token. So we know that token is not generated by someone else maliciously. So they would hack into our server. We know that they would have to know our secret string in order to create the same type of token in a way. So only we know our secret. We never share it with anybody. So we know that we verify the token came from us and the token is still valid. And if it's valid, it passes. If it's not, it would throw an error and it would catch here, and this error would be handled by our error handler. Anyways, so the data inside that we packaged, remember when we created the token, we put inside ID of the account, data, full name, email of the account, some like small amounts of data like that. So all the data we get from verify that data, you can console log here to see everything. So basically, in this request that is moving on now from this middleware to our actual other method that's gonna process our request, we are gonna say request.account, we are gonna store our data basically in our, so this is what happens in the auth middleware. So now in the controllers middleware, if you go to this endpoint, so this endpoint has this authenticate middleware. So that's a second middleware we created. If you remember, so auth middleware attaches a request.account if the token is valid and so on. And then this middleware, additionally, if it's added as a middleware, will check if a request.account exists. If it doesn't, that means that your token was invalid or you didn't provide the token, and it will throw an error 401 saying you are unauthorized. But if it finds request.account attached, that means that auth middleware before that did find the token in the headers, the token was valid, and it attached a request account, the data from the token. So basically just checks whether you are authenticated in that sense, previously logged in to our API in that way. And then you move on here. So here, the /account/me, we just return you back some login details. so your browser app can knows, yeah, you are the user, this is your full name, email, a bunch of data we want to return. So in Mongo, this is one of the, we use the find one methods for this, for collection accounts or whatever. There's also aggregate method where you can put much more custom logic. I didn't need to do that, but I just did it, so I show you that this is also one of the ways you can do it. So it gets a bunch of stages. You can have many match stages, and the match here, the values should be like, oh, ID is this, data, email is some value. So it basically searches all the accounts with this query that we are gonna pass. And basically project means, what do I want to return from Mongo? So we have underscore ID. If you put 0, this is not gonna be returned by Mongo. If it's 1, it will return that. Or for a property, you can say it's an object, and then full name is a $, a root. So this is just a variable in Mongo, like a root document, and then you can access with that notation. So basically, you're saying root is this entire thing. So in Mongo, you're just saying root.data.full name. So this is going to be stored in a full name and email. So we are not going to return security property. That's why we are doing this. Like, we are packaging a custom thing that Mongo will return to us for this account. And basically, typing to array will return, basically, because we are only going to find one account with this ID, it's going to return an array with one element. We just access that element, and this is our account. If we didn't find any account, we throw a new validation error saying no account found. Otherwise, we just return it as a JSON response to the browser. And get account details once you log in, so you can display them in your React app. I showed you how to authenticate, basically send email and password to get the token back if the email and password are correct. And then for the posts controller, we have create post, get many public posts, get one public post, get many posts that the user who is authenticated created. This is for the React app. And then get, update, and delete posts. And basically that's it. So now create, we register route, which is /posts. So it's a post request to /post. So we are going to create a post. We authenticate whether you are already authenticated or not, because you have to be an existing user to create a post in our database. You cannot be like a random person sending a request. We validate if incoming schema, incoming JSON as a request body you sent is based on our schema that we defined. You can trace this back to the validation folder to see how the schema looks exactly. Then basically, additional thing we do is in request body, we add a meta object, and inside we say created by, and we store like the account who created it. So later when we query like posts in your, you remember in the React app in the homepage, we only show posts you specifically, that user who logged in created. So in order for us to know who created what post, we have to attach some reference to the post, and we can attach the account ID. So request.account, this is the account the auth middleware attaches to the request. So we have a request account ID. We attach it to the meta created by of the post in the database. So if you go to the database, like right here to the posts, this is the meta we added, and created by, this is the reference of the account who created this post. So we know exactly who created it. So later down the road, we can say, give me all the posts where meta created by is this account. So it gives us all the posts from created by that specific account. So basically, we're just leaving some references so we can later query them in the way we want to. Again, same way for the account, it's a model, or basically just a regular JavaScript class that packages the object that we are going to save into the database itself. We create a post in the post collection, return some response, blah, blah, blah. Get many public. So these two endpoints are used by Next.js. We are not, so we are trying to find all the posts, and we are sorting by receive that -1, meaning from newest to oldest. And we are returning all those posts. And here you are defining a route /public :id. And here is how you access it: request.params.id. You get the ID from the URL. And then in the database, you can just say, find me one post where the ID equals this ID. Basically, that's it. If there's no post, we throw an error. There's no post, otherwise we return it to the Next.js browser app. And these are all the posts. We are not narrowing them down by who created them or not. This is and mind you, there is no authentication middleware here because Next.js app doesn't have any login. So that's why these two endpoints don't require any authentication. Anybody can send a public request to these. That's why I call them public. Like you don't need to, every request that doesn't need authentication, you don't need to preface them by a public keyword. This is just what I've done for this just use case, that just to separate them from the other endpoints here. And then get many endpoint is basically in the React app in the homepage. We are just saying basically return me all the posts from a collection posts where meta created by, dot created by equals my request account ID. So me who is making the request, I need all posts that I created myself. Just give me all of those. That's it. And then the get, it just returns the post, finds the post that this. Additionally, here you can say ID equals this post ID, but also meta created by equals my account. I don't know why I additionally did this line after that, but we can query the post like this. It doesn't matter. Here I additionally made this check that also the post I'm trying to get is the post I specifically am the author of by checking the post I got from the database, that post meta created by. If it isn't equal to my ID, I throw the permission error, like I'm not the one who created it, I cannot get it or update it or delete it. Here for the update, it's put request for /post/ID. You have to be authenticated. We validate if the JSON schema you're sending for updating a post is based on our schema. We find the post. If it doesn't exist, we throw an error. If I'm not the author, we throw a permission error. And then basically this is how you update in the MongoDB. There's a method called find one and update, and there's an ID. There's a first argument is whatever query to find the post. The second one uses this $set keyword, and the data is like this. So if our post is like this, so our post is like data, and then inside we have title and then body, like body text. So if this is how the post is stored in the database, if you want to update a certain field, the data you pass to set has to be like this. So you have to have data dot title updated, whatever data it is. So you have to access the properties you want to update in your Mongo document with a dot notation in order to update them. You cannot send this to the MongoDB exactly and it's going to be updated. No, you have to do this. So basically this is the code that I'm doing just to loop through all the data properties and then say data and data dot whatever keys, whatever value. So basically I generate from this, I generate something like this that I pass into the $set as a value. And then I just say return original false because this function by default returns the original document, not the updated, just now updated version. So this now will return just now updated version that we can send back to the browser as a response. Delete one also fetches the post, checks if I'm the author, if I'm not, permission error. If I am the author, there's a method called find one and delete. And basically finds the post, deletes it, and we send back a response saying the post is removed. Basically, that's it. This is all our endpoints and everything our API does that our React and XJ app use basically to show and to work with. Now, the last thing I want to show you, the very, very important thing is how to run tests. So we don't want to create an API, not test it, and there's like a bunch of bugs inside that we didn't even notice. We deploy the server online, people start using it, and it starts crashing or showing a bunch of bugs. Before we do that, actually deploy it online, we can write some automated tests, so like testing code, so we can test each endpoint if it's performing exactly as we want intended it to perform. So we can write tests and check all the logic. This is done by using the library called Mocha. So Mocha is the library. So it has this test. You can just run the Mocha keyword. You can run this command in the console, and it will look into this file .mockarc.js for the config, what to test. Basically, it's just saying, what do I want to test? So it's basically testing everything in the test folder, all the files that inside of themselves end with .test.js. So all those files will be considered testing files, and those are going to be ran by Mocha tests. Now, what we want to do, and this is the key thing that you can do, the database we have deployed online. This is just for actual production. Production, what we call, is when you deploy the app online and people actually use it. We are not going to use this database for testing, because for testing, we want to insert some dummy data into our database. And then once the tests are done, we want to delete the entire database. And then when we run the test again, we start the database, put some dummy data inside, try to make some API calls, see if it returns it properly. Once we finish the test, we delete the database again, and so on. So we don't want to do that with this database we have. What you can do is you can run the database locally yourself. It sounds more complicated than it is, but you can download the Docker. So the Docker is basically like a zip, like a database comes in like a zip file, and you can start it with one command locally. And instead of using the URL to our actual database for running tests, that's why in package.json, so I think we already went through this. Sorry, I'm jumping between files. So in our package.json, we use this cross-env, which is also like a plugin we installed here. We set the node env to be equal production when we start the server, or to equal development when we locally develop. But when we are running tests, we set it to test. Why this? If you remember here, .env file, we have .env.dev, .env.test. So when we are running tests and we run that command, the node env gets set to test. So we know that the Node.js environment we are currently running in is a test environment. So in this case, dynamically in our config, if you remember, if our process.env.nodedev equals test, then load all the environment variables from .env.test, otherwise from .env.dev. And .env.test has our local MongoDB link. So link to our locally running MongoDB, not the one we signed up for and we are actually using in production. So this is the link MongoDB://localhost 27,017, blah, blah, blah. So this is our local database. But how do we get our local database to run? So you can install the Docker. You can even type install Docker on install Docker, see Docker desktop, Docker hub. The Docker desktop, this is what you actually need. You can install it for Windows and it will start running. For example, I have this basically application, and this Docker is basically so the database, it's like a whole application, right? That you can run locally on your PC. So the Docker creates like a zip file of the database and just easily installs it locally so you can run it, and that's basically it. So I'm going to very quickly show you how to do it. So you would install Docker and you would see once the Docker is officially running. And then you also install Kitematic. So Kitematic is the app that helps you, like it's a UI for the Docker app that helps you like in one click start the database, stop the database, and so on. So if you install Kitematic, and we see now that our Docker is officially running in the background. So here you have a bunch of containers. That's how it's called, like Docker containers. So each app is like a container, whatever. So here you have a bunch of things you can search for, and one of them being MongoDB. You can find it here, and you can click create. Once you do that, you will have a Mongo container here, like you just created. One thing you should do is go to settings, go to hostname and ports, and just copy this port, copy it here. You're going to have something else in the beginning. So copy it here, click save. Once you do that, you can click on the MongoDB and click start. Now it automatically started. So now our local MongoDB is running, and we don't need to authenticate with this local MongoDB. We can delete stuff, delete the entire database, insert anything we want to into it without being scared to mess up our database that's running online. So once you do this, link to your MongoDB will be this exact link. So MongoDB /:/ localhost : 27,017, and then basically question mark retry writes equals true. So basically this is going to be our link. So once we run the tests, here we have a couple of things. Fixtures is basically nothing special. We are just creating a method where we pass the database connection that we have, and inside of that database we create a collection of accounts, and we just insert many like documents. We insert like, this is like test data we want to insert. We want to say this is account 1, this is its email, this is the password, blah blah blah. The ID of this account is 1 and this account is ID is 2. So we inserted 2 dummy accounts, and then we inserted a bunch of dummy posts, actually 2 of them, post 1, post 2. And index.js is just a function that inserts both dummy accounts and dummy posts if you call it. That's it. You're gonna see in the controllers right now. So here in auth controller, for example, or for example account controller. So this is how all the logic is. You don't need to understand too much. Basically, the chai is the Mocha testing framework, the Mocha, the library we installed to run tests. Basically, it works like this. You create a describe function. The first argument is whatever you want to name it, and then you have the second. So let me. So basically, the second argument is a function. So inside of that function, before anything runs, you can run this method and you await setup. And inside of the setup, I basically imported insert all method from the fixtures, and then I establish a database connection from our helper tools. So here you can go database util. It basically fetches the Mongo from our source database Mongo, and it establishes a connection and returns this database connection object, whatever. And basically, if you track back to here, accounts, we get a connection. We pass the DB to our fixture, so it can actually insert all the dummy data. We can generate these tokens like as we are authenticated with this method. You can always also go back. So to this method, we pass fixtures, or basically the dummy data we just inserted into the database. We loop through every account, and then we actually create the token, sign it with our secret, same as we would do it like in our API. So basically, we are just creating a bunch of these dummy data so we can test our API. So now here, we then can test each endpoint. So within this describe function, we can have nested described blocks of code, block of testing code. So this describe, again, what we are describing is what we are testing is /accounts endpoints, and now you can use this it function. So it basically runs the test. So describe a block is just like encapsulating certain chunks of testing functionality, whatever. So here we are testing, in this describe we are testing /accounts, and here we're testing /accounts me. But for /accounts, we want to test different scenarios. So if there's a validation error, so basically the server we exported from our source index.js, you can go back there and see how we exported it. So again, you don't need to understand much. This is chai HTTP, those are libraries. We say chai use chai HTTP. I don't go into these details. I just know that this is how you send like an actual request to your local server to test it. And then you say await chai and then that request, pass your server instance, and then you just make like a post request, get request, put request, delete request, anything you want. So here we are making a post request to /accounts. We can send some JSON like this, send, and we send some data. And basically this is invalid. And essentially, here is how we test. We either use the should keyword or the expect. So we say the response should have status 400. So if this is correct, because there's a validation error, the status from our API should be 400. And then we can say that we are expecting that response body. So this is the response we got from the server. So this response.meta that message should equal data email is required and data security is required. This is the validation error we got. So basically we are saying we are expecting that this dot equals this. So this is our test. And if this passes, then it means that our endpoint is behaving properly. So the point is, so then again, the next scenario we want to test for the same slash accounts endpoint is the correct one. So actual schema we should send, and we should, I don't know, test some of the things like we expect that the response.id is going to be a string, whatever. The status should be 200. So it's successful request. So the whole point is for the slash accounts or any endpoint, we want to test various scenarios. Like when there is an error, is the message we are getting proper? If we don't send authentication, did we get 401 status code, like we are not authorized? Is this also behaving correctly? And then if we succeed, so you both test error cases and successful cases to see if your endpoint is behaving properly. And then we do the same thing. So slash account slash me, you have to send the token in the header. So basically, if you just say get accounts me, we should get 401. So we are not authorized. But if you go to get slash account slash me, and we set, so you use set keyword, you use send keyword to send JSON in a request body, but you use set keyword to set some header key values that are passed in the request headers. So as we said, you pass token in the headers in the property named authorization, and the value should be our token. And this token here, because we generated these tokens, you'll see in that method, it basically returns exactly what we expect. So API token, and then whatever the token is. So this is what this will return here. So basically it's a valid token for account number one. And then that means that we send all the proper things in as it should. So it's authenticate the request to slash account slash me as a get request. The response should be 200. And the response body, we can check what we got back from the server. Yes, we got the response is the account object with the ID, data, full name, and blah, 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 everything we need for the front-end app. So basically all of this, just repeat it for everything else, for posts and so on. You can test everything, how your API endpoints behave. Are they handling errors properly? Are they handling success scenarios properly, returning proper data, proper status codes? That's pretty much it. It's not much more than that. We insert some dummy data and so on. For the post, it's the same. Slash want to create a post. If you didn't send any authorization, any token in the headers authorization, you are going to get unauthorized 401. If you didn't send proper schema, you're going to get validation error. And then this is valid. We send both token to authenticate ourselves and send some proper JSON data, title, body, tags, whatever our schema defines. And you get a proper status code and response back from the server. If you want to get a single post, if you want to update the post as well, so you make a put request. If you want to delete your post, you make a delete request, but you have to be authorized. And by the way, we also check, if you remember, so the post number 2 is created by account number 2, but we sent a token from account number 1. So we don't have a permission to delete his post. This is the logic we done in the controller. So this is very important for you to check for these edge cases. If someone is maliciously trying to delete someone else's post, did you handle that logic properly in your API endpoint code? If you didn't, you have to handle it. You have to put some more if checks saying if you are if you're not an owner of this post, you cannot delete it. So that's why these tests are very cool, because they can uncover a bunch of those bugs you didn't cover in the code that you should have, right? Basically, that's pretty much it. One thing is, after method runs after all these tests, and before method runs before all these tests. So before all these tests, we insert all this dummy data. And after all these tests, we clean the database. Basically, we drop the database. So the database that's currently running, the local one, we call the drop database method, and just deletes the entire database. And the next time we rerun the tests, it again starts up the database, inserts dummy data, and so on and so on. Because every time we run tests, we should start from a clean plate, insert dummy data, test that dummy data is that all correct, our API endpoint is behaving correctly. We delete it again and start again. We always have to start from a clean plate, so we know that our tests are working with 100% clean data. We know that data wasn't messed before we start running the test and so on. So we are 100% sure that tests we are running are correctly running. On yarn test, you should start running all our tests. Runs run, and it basically gives us a little check mark. So it says this controller accounts, which is basically this. It literally logs whatever we wrote here, and then it goes into this describe block, which is this, and then it tests the validation error, and it tests this success one, and it gives a check mark how long the request took. Is the correctly test passing correctly? All the 23 tests are passing correctly, and by this we know that our API is a very solid API. It works properly. It works as intended. We cover all the bugs or edge cases that can create some issues in our code base and so on. Basically, that's it. Testing, authentication, the middleware, handling errors, basically a bit more validation and all that stuff is new stuff on top of what we already went in the tutorial. But I know it sounds hard because there's like too many new things, but that's why I said this is just so you are aware in like a professional app, all the things you have to cover. You have here exactly how it's done. You just have to sit down, repeat it many times, copy paste it until you get a gist of how it actually works and you understand it enough to implement it in your project, in your work tomorrow, right? When you get a job. And again, even then, you don't have to know all of this, like memorize everything. You just have to understand how all of this works. And then if you have, and you do have a code base that I will leave you here, I'm never gonna take this away from you. So like you have this, you can always copy paste it, see how I implemented it, you also implement it on your side. That's it. You just literally copy paste what I've done, try to understand what's happening. That's pretty much it. Like this is what you have to do. And over time, it will get into your muscle memory and you don't have to worry about it properly, and we ran tests, then now we know that our server is ready, and now we can create a React app that connects to our server, uses it, and so on, and also our Next.js app. So our React app, it's basically a normal React app, but I added a bunch of little things to help us build a more robust, advanced app. And basically, I didn't need to do a bunch of these things. I've just done it because this is what I've used daily in my own work. And over time, you'll realize how it works. And once it gets into your muscle memory, again, same as for the API, you can copy paste it, try to understand just briefly now how it all connects and works together, what these tools are, these libraries, how they work, and so on. And basically, that's it. Like you don't need to memorize everything right now. You just need to try it over time, try to copy paste, try to change some stuff to see what changed, to understand like when you change stuff, add new stuff, how it behaves, and over time you'll figure out everything. Like it's just basically that's pretty much it. So in the dashboard, we have a couple of things. So we created a sign up page, sign in page, and then we created like a home page where you can technically have 3 more sub pages. One is to view all the posts you created, create a new post, and then see the individual post. You can update it and so on. So basically, that's what you already shown you. So in the source, in the index.js, we have our main app, same as before. It's attached to the DOM right here. These are a bunch of different details, polyfills. You don't need to really know about it right now. Just move past it. And in the assets folder, we have our images, some SVG. SVG is like an icon. It's not a regular image. It's an icon itself. So there I also have my logo. And so now in the app itself, we have a couple of things. We have components folder, config folder, modules, services, and utils. And we have these things. So components is where I store all React components that you want to reuse across your entire app, like a UI button. Button you want to use in a home page, button component you want to use in a different page, blah, blah, blah. So those are things that will repeat and you are going to reuse in many different places. So basically, here I have a bunch of these components. So one thing to note is I'm using Material UI library, and this library gives you like a bunch of React components you don't need to make from scratch, like inputs, buttons, sidebars, bunch of that stuff. Why I don't create all those components myself is because they created very solid code base for all of these components. If you start building your same component yourself in React, a custom button component, I'm sure you're not gonna get even close to the quality they created. And they also give you this out of the box, so you are more productive using their own components. So for example, button component, look at what they give you. Like basically they give you the button component, this is the text inside, and they give you this API, like a variant can be contained. It looks like this. If the variant, if the button, the variant is equal text, um, give me a second. So if the variant equals outlined, the button looks like this. It just has a border. And then if the button is disabled, if you pass this property to their button component, the button is not clickable anymore. Um, Basically, that's like, but they give you a bunch of sizes. So if you pass a size that is small, medium, or large, you get a different like size of the button. So they like created a bunch of different components that you can see here that you can extend and like use in your own code base. You don't need to reinvent the wheel for all this stuff. Their components are more than good enough for all of the projects, and you can customize the colors, how the components look, how the button looks as much as you want. So basically what I've done is in app components UI, I created a button component, and it's my own custom button React component, but inside I actually return their button component. I just extend it, customize it a bit for my own code base. So I want to say that all my buttons by default are variant contained. They're all primary buttons. They're all size medium. And then if I pass a property called loading true to my button, then I'm gonna show you like a circle of progress, like a small spinner icon. And then if the loading is false, I just remove it. So this is like additional logic I added to their own button. And then basically in my code base, I import this component, like my own component, which extends their own button, just adds a bit more of my own functionality inside. And also, very cool thing that this code base gives you, it's a separate library, but they implemented it here, is called JSS. It's CSS inside of JavaScript. So basically, you just need to type it a few times to get into your muscle memory. The only thing you have to do is basically use these make styles from their own Material UI/core or styles library. You make styles, this is a function, it passes, you get a theme, and it returns an object. And this is basically the class names, root, size large, small, contain, whatever. Inside you can put a bunch of CSS, or like normal CSS, is just not a regular CSS file. So it's in JavaScript, it's all camel case. So font weight, not font minus weight. This is the only difference. And then if you want to add it to your component, you say const classes equals use styles. So you call this method and it returns all the class names. And you can just say the class name of this button is classes.root or classes.sizeLarge. So basically this is how you attach the class name, the class you define here, to your custom component. And you will see it in an example down the road. So basically I have in my components bunch of elements like this UI, which is like just dummy element, just bunch of buttons, stuff that doesn't have any state inside. It's just a normal button, nothing special. Utils, it's like you'll see a custom React hook I created, for example, for having a form, like handling the state for creating like any kind of inputs and forms and validating input, blah blah blah. You don't need to understand that now, it's too complicated for you right now. And the widgets folder, widget is what I call like a chunk of functionality, like a header. So what is a header here? A header here is, this looks like a lot of stuff. You don't need to understand like almost any of this. Just generally my header is like it has this div, the class. So the class name attaches classes.root is basically this exact what I just showed you, like Java, CSS in JavaScript. So this is like my header is fixed. It's on top left, blah blah blah. And then I add their own Material UI component. It's called app bar, and the toolbar inside has three things. It has this icon button with icon from Material UI. So basically, once you hover this, it's same like here. It's this like icon. Once you hover it, you see this tooltip. So basically, this is what it is. So it's a tooltip. The icon button is wrapped within their own tooltip component. Once I hover it, I see the tooltip floating thing, and then it's an icon button. Inside this icon button, I pass the icon itself, and then this is how you import their own icons, Material UI / icon / whatever. And in Material UI, they have a bunch of icons you can import. Material UI icons. So basically here you have a bunch of icons, outlined versions of them. You can use in your own app, and you enter one, and they tell you exactly how to import the icon itself. So here is basically that's what's happening. And then once you click on this icon button component, again, their own Material UI component, we switch the theme. How we switch the theme, I'm not going to go into that right now. This is my code which you can reuse. It's very nice functionality, but it's too complicated for you right now. It's not generally that complicated, but once you get to that level, we can discuss it. And then the link from the React Router DOM, whenever you click on it, it routes back to, and remember we did this before, it routes back to the homepage, to the slash. And the link, inside the link, we have our logo icon. And the logo icon is my own icon in assets, SVG, logo, SVG. So that's my own icon. This is how you import it in React component as logo icon, and then you can just use it here like a React component. This is how you can add it. And then the third thing is the menu, the drop-down menu. But again, you can see the drop-down menu inside these components is here. It's a React component itself. Again, it looks more complicated than it is, but for me, it's not, because I'm used to all of this stuff. For you, you can, if you have time to sit down and really dive deep into this, try to understand, okay, this is an avatar, this is a component from Material UI. So if I go to the to avatar, I type avatar here, it shows me that it's just a circle with something. So when I clicked top right corner, I saw the avatar icon, and then there was like my name, and there's like sign out button in React dashboard. So basically that's what it is. I made that drop down menu, and this is the code how to do it. Like, it's an avatar, and there's a menu, and we only open the menu if somebody clicks on it. So if somebody clicks, this is the code you can always also find on their own website. We have a state here. It's an anchor element and set anchor element. Whenever you click on it, the position of this avatar, like basically that's the anchor element, the current target. This is set, and then in this menu component, again, the Material UI component, I didn't make this myself. They made it. So that drop-down menu knows exactly. So if I click here on this, button, sees this right here. So if I click here, what the menu does is it takes this element, finds its position on the screen, and then shows this drop down right below it because I clicked on this one. That's basically what happens here. If I clicked here, the event current target is basically giving me the location of this avatar on the screen, which is exactly this, and I'm passing that set anchor element to my state, and then that variable I'm passing to the menu component. So the menu component knows exactly where to show. It knows exactly where my anchor element that I just clicked is, and it just finds that position in the DOM and just shows right below it. So this is how this drop-down element works. That's the logic I just explained to you. And then inside that menu, we have a bunch of list items with a divider, and this list item has a sign out icon and how we can sign out from our app and so on. So basically, those are some header widgets, and then you can feel free to go into the footer to also see how I made a footer component, some CSS, regular footer, like typography from them as well, a component. Inside you can add like some text, some additional whatever, the dot between it, the blog, blah blah blah. I added some inline CSS as well here, so it's basically you can roam around this code base and see how certain things are done. It's going to be more useful than just watching me explain a bunch of this stuff, like every single detail. Now, those are like reusable components. This is just a bunch of classes that encapsulate some sort of functionality from our API. So all the methods that contact our API for accounts is inside account service. So basically I have a create method, which just sends a request, post request to our, whatever the API endpoint is. Here I put it in a config file. So it's HTTP localhost 5 port 5000 if you are running your API locally. And the route is /accounts, and we pass some data to the request. So this is how we pass JSON data in the request. And I also made a request service. And what is a request service? If you go to the request service, it's just an Axios library. And then in that Axios library, in the request service, I just made like 4 methods: get, post, put, and delete. And then each method is basically just sending a Axios get, post, put, delete request. And we are passing the URL, the body, if it's a post and put request, to the Axios library. And this is just basically how it's done. Now, the cool thing about Axios library is you can make these interceptors, meaning you can intercept a request and intercept a response. Intercepting a request, meaning if you trigger a request here, before the request is actually sent, it goes to this interceptor. So in the auth service, if we logged in and we got the token from the server, the JSON Web Token, that token we save it to the local storage of this web page, which we are going to get to. And then if the token exists, I attach it to the headers. So authorization, API token. So this is how I attach token to every request I make. So I don't need to, basically, this is why we do it in this one place here in the interceptor for every request I make, not to repeat the same logic like in every place I make a request. I just put it in this single one place. That's why this Axios library is useful, because you can organize your code to be very simple in this manner. So auth service. So when you initially sign in, and I'm gonna show you this. So in the source and then app, and then this is how I organize my pages. So my main app, again, don't get scared from all of this. So Material UI gives us this theme provider where we can pass a theme object, which basically gives us a bunch of colors for texts, for backgrounds, like font sizes, and a bunch of like standardized theme. Like that's like a theme object defining a theme for our app that we can reuse throughout our app. So we don't need to hardcode colors for every font everywhere. All the fonts all the text will just inherit the theme colors. That's why it's very useful to use this Material UI library. So basically you wrap your entire app. This is our like main entrance. So we just wrap everything in a theme provider. You basically don't need any of this stuff. The only thing you technically need is this part right here. So to use the switch and the routes, that we did for like switching from a home page to about page, you need to wrap everything inside this router from React router DOM. So this router, and basically we pass some history objects, blah blah blah. It doesn't matter. So now the routes, before I inlined, like inside here, I put like switch and route and blah blah blah. But much cleaner way to do it is I created like a routes. All that switching between routes, I put it in I always put it in like a separate file, like its own React component. And again, don't get scared about any of this stuff. Technically, you don't need any of this. Aside from this thing here, you also don't need this use memo. You can just make this a regular array. Basically, what this is saying is, if in auth service our method is logged in, if it says yes, we are logged in, the only route it returns is with path this, and it renders the main component for this route. If we are not logged in, so if we are logged in, it renders this. Otherwise, it returns this. And this array has sign in and sign up. And what this actually does is basically, if we are signed in, we can only visit our homepage. and we cannot visit these other pages. They will not exist because only this route will get rendered in the switch. And then otherwise, if we are not logged in, we cannot visit the home page. We can only visit these two routes. So basically, this is all this code does. And then I'm literally just looping through this array right here that conditionally gives me routes based on if I'm logged in or not. This is what this function basically does. And I just loop through all of them, and it's basically a switch object with route objects inside. We already done this for a home and about page. I just did it in a more dynamic way. So item path is this, component is this, the component I'm trying to render. You can also just put here like item.component instead of all of this. This is just a more advanced code I've done over time. Again, have in mind, you're looking at my very advanced code base that I've done over a few years. It's not a beginner code necessarily, but you know, it is what it is. Better for you to get through all of these weeds right now, and then if you did it successfully, like you are going to be a very solid developer moving forwards. And basically this is like where my routing happens. Like if I'm logged in, I see the home page. If I'm not, I see the sign in page. If somebody clicks to, like, I don't have an account, sign up, they go to the sign up page. And all of these components, this is why what I call modules. This is the difference between a module and a component in my own setup. So it's the module is also just a custom React component. The component is also just a custom React component, but the difference, I make it like this. I separate it because components are just header, a button, something like just a UI element or like a widget, but it's not a component that represents an entire page. Components that represent an entire page, I put it like as a separate called files like this. So it's a sign-in component, which represents a sign-in page. So basically here, again, CSS in JavaScript, blah, blah, blah. And this is how, again, I'm not going to go through much through this, but technically what you see in this page is I have like a main div. Then I have a link at the top with my logo inside, and it links to whatever. And then inside I have my own title, custom title component, and I have my form. And inside my form, I have a text input field where you can type your email. I have a password input field where you can type your password, and then a button, which when you click the button, it basically submits. So if button is of type submit, then you click it, and then it will call this on submit method because you wrap this is how the HTML form element works. It's gonna call this on submit method, which we passed a reference to our on sign in function. So this on sign in function will actually get called. And basically this is what I used, like a custom hook reacted where all the values. So if you pass on change to here, form on change, and the name is email, the form.values will contain, once you make some inputs here and here, the form.values will be an object with email and then whatever you typed, and then the password, whatever you typed. So this is going to be the result, essentially. So the form values is what all the values I have, so email and password, and I pass them on to my auth service login method. So in this service, I'm actually passing, so this page, sign in page, I'm just taking some inputs from like email and password, and then the logic of actually logging in, sending a request to my API with email and password, if you remember, this is all happening in my auth service login method. Why there? Is because all the logic that contacts my API, I like to store in my services, just so the code base is clean. All the logic that contacts my API, I want to be in like one single place. I don't want some logic to be here and some logic to be in a sign-in React component. It's very messy. So here we only put all the logic that contacts our API. So everything that has to do with the auth, basically login endpoints in our API is in the auth service. So that by that logic, we have a login method where we in the data, this is what we just passed from the inputs from a sign-in component. Here we would have in object, we would have email and password. And basically in our request service, we are sending a post request to /auth/login. That's our basically API. And the data we are sending, the JSON data is just email and password. And then our API will send a token back. And if the token there's a token, there's like a request error, it's gonna be stored here, it's gonna throw an error. Otherwise, I have a storage service. So storage service in the browser, one important thing, if you go here and then application, every web page has this local storage. So local storage is just a bunch of key values for your page, so you can save some data. Like if you're logged in, you want to save this data into your local storage for your tab, for your browser app, saying this is the user who is currently logged in. So basically the only thing I'm doing is I'm saving a token here, I'm saving like value token, and then whatever my token actually is. So when somebody refreshes the page, I can read from the local storage. I can fetch the key of token, get the value of this token, and then make a request, right? Uh, this is gonna persist. This is the thing. If you save this, I got this token from the browser and I saved it somewhere here in the class. When you refresh the tab, the entire JavaScript you previously that was running gets deleted, cleared, and then the new version of just new code base starts running after the refresh. So if we stored it somewhere in the code while the browser was running, the app was running, that would all get lost. That's why we don't log in every time we refresh the app. That's why, because we save stuff into the local storage, and then every time you refresh the app, we read the stuff from the local storage and we keep you signed in. That's pretty much it. Storage service, again, you can go to my services, go to the storage service. This is my own code. Basically, this is how, so the storage is called local storage, and the methods on it is set item, get item, basically that's it, and then like delete item, remove item. These are the methods. Like to, so basically, if in this page I said local storage set item token, and then the value was 1 to 3, if I did this and I went to application and then local storage, I can see that this is what I set right here. Anyways, so basically services, and then auth request to get /account/me, if you remember that API endpoint, which returns like details about our account, and we also store that in our local storage. And basically then we trigger this this auth next login, blah blah blah, what it actually does, and then we history push. So this is how we can from the code redirect to some page, like not clicking something, but like directly from the code. You can get this history from utils. You can just say push to whatever route is, like a dashboard route, whatever. So basically, I'm not gonna go through the sign up logic as well. It's also like a basic page, React component. It has some inputs, full name, email, password. Once you click sign up button, what it does, it calls the sign up method. This is the request that we expect to receive for a sign up. So full name, email, security, and then password inside. And then we have account service.create. So basically that's it. And once you officially create it, I redirect you to the sign in page. Basically, that's pretty much the gist. And then of course in the services and account service, you can see that the create method just sends a create request to our /accounts endpoint to our API and passes that data to it. It's a post request. That's pretty much it. Here is the main, like this is our like a main dashboard app. So we have a header, main, and footer. Like once you log in, and how I structure this is because this is like a shared logic. So every page, once you log in, has a header, a footer, and so on. I put this in a main component, and this is what I render first. And then inside, I nest more routes in. So like I nest into these routes additional routing. And this is again a separate component. And basically I'm saying if you go to /posts, load the posts component. If you go to /post/new, load this post new component. If you go to /post/:id, go to the post component. And then if you don't go to any of these, but you go to some other route, redirect to /posts. So this is what the redirect component is. It's all in a switch component. It's basically pretty much straightforward in this sense. And then you can just enter each component in a containers folder and see what the component does. For example, /post component doesn't do anything special, just fetches all my posts. So it gets many posts from a post service. You can go to that method to see what it is. Just contacts to our API, makes a get request to slash posts in our API, gets all the posts, save it in the state. We call this function, like in this use effect, we said we only use it like this. You want to call it initially once the component initially renders, and my custom title component, and basically we go through all the posts. So it's posts.response.map. Here is, this is how our server returns the response, and then for each post we return like a basically a link component that whenever you click on it, we history push to /post/post ID. So again, from the code, we can do it like this directly if we want to. If there is no post, so the length is 0. So post.response.length, it's an empty array. This is how you can check it. Like if you add this and then the post response length, because array length is, so empty array length is 0, and if you add this to 0, it returns true. So if this is true, we know that we don't have any posts, so we have just gonna render no posts here, right? Like a key, like just a small word. And then basically post is basically just we fetch, we get the ID from the window location path name. We can like extract the ID from the URL. Once we get the ID, we can get the post with that ID. So post service get a single post with this ID, and then we're just gonna initiate our form. So the values title and values body, we're gonna set it to whatever the values are for the post we just got from the server. And then basically we have some text input fields for the title body, where the value is form values title, form values body, and on change, because this is the name title, the value is going to be updated to whatever form values title is going to be updated to whatever we input additionally. And then once you click a save button, it's going to trigger their own save method here. And basically we can update. We have a method post service.update. We pass the post ID and whatever the body, like the title and body, we updated from our inputs, basically sends a request to our endpoint /post/colon ID as a put request, so we can update our post. And basically that's it. Like if we go here and then basically here, we can see that this method is basically just sending a put request to /post and then ID, passing some data we just edited to our API, and then that's just making this request towards our API. So essentially that's it. Like you can additionally see containers and then post new, how we create a new post, but it's basically the same logic repeating over and over. Similar logic, basically text input fields for title, body. There's a button create. Once you click it, it triggers this onCreate method, which is right here. And basically if the form is valid in that sense, we create a post. So post service.create, it's a method. See how all the services have, again, all the logic contacting the API in the service, so the code base is as clean as possible. That's the whole thing, like how to keep the code base very clean, because you see that the amount of code easily starts stacking up over time as you add more complexity to your app. So organizing things in services, this is how I call them a service. It's just a normal JavaScript class that inside itself has some methods that do some stuff. That's pretty much it. So that's our React JS app. It's a very simple, like we didn't change much. We have pages like we did in a tutorial. And then we have components. Inside we have some UI elements, basically a button, same as like in a React app. The only difference is from the tutorial, if you go to the basically source folder and then pages, in the app_app.js, the difference between this and like how we did it before we didn't do much. Here we have a theme provider, same as in React.js. So this is our like intro into the app. Here we add some of the next progress, whatever. So we see the progress bar if you change the pages. So that's like a plugin. Then the app component itself, and what app component is like a basic React component, but what it does, if you go to it, not that, sorry, it redirected to the wrong thing. So here, source, and then app, and then components. Sorry, not UI, widget components. So the app component itself is just a container which has a header, the main, and the footer, and whatever we pass else. So this is how I reuse logic in Next.js. Any page, if all the pages share header and footer, I make like a one container component that has header and footer, and everything I wrap in that component around those like other children of this component go here. So basically all the pages like a home page slash post page slash colon ID basically. So we have two pages, is just a root page, which is just like a home page with a bunch of blog posts we are gonna render there. And then when you click on each one, you go to slash colon ID. So basically slash post ID. So basically only those two pages. So here the children will be either home page or that single post page. That's how I made a logic to reuse header and footer, not repeat it in both pages. So if I go to pages and then index.js, this is our main page. So the only thing that happens here, so before here we made in index.js directly, we made all the logic, everything we needed. But how I actually do it in real life is what they tell you in Next.js, you just have to here export a component. You just have to export something. So I created my posts component, which is the React component where actually my logic is done for the homepage. And I just return. So this is a React component. It's a function which returns with props, and it just literally returns my post component. But additionally, what they tell you in Next.js, and this is like one of the main things, if you export an async function called get server side props, you can make a request to fetch something and then pass those props to your component. So basically all the props you have here, so we fetch many public posts and we basically add it to the props.posts, and then those props will be passed into this page from index.js, like right here. Essentially, these props will be passed to our post component. This is the structure of Next.js, like how you can do stuff, and you just need to follow that logic. So the same logic we do for, and this is how you define a route for like any ID. So basically slash, this is just a root route, is just a slash nothing. Index.js, this is our homepage, and then slash post ID, because that's a variable, it can be anything. This is how you define it, angle brackets and put ID inside. And the same way we do here, we just return post component and get server side props, because it's like a Express.js server, you get params. Context is like a request. So request.params, request params ID, same as in our Express app. Basically get the ID from the route, and we can get that public post services, same as React. Like I created services that talk to our API. We get a post back, and then we add that post to the props, and those props from this function in Next.js will be passed to our page here, and our page just returns our custom post component, basically like in React, like our page. So bottom line, what will happen is for the home page, if we go to the pages folder, so this is the difference how I do it here. So we have a post page and post page. So posts page, we don't need to fetch posts here in use effect because we already done it. I just showed you how and when. So before actually sending the response to the browser when somebody visits this page, we first fetch stuff and then we return this component. So this is why it's important, because remember, in Next.js, we need to send pre-populated page. We cannot send like a React component because that's the issue with React. If it sends out like an empty page, then the search engines cannot index it for search engine optimization for the search results. So we need to, before we send the response, the page as a response back to the browser when somebody visits the URL, before that we have to fetch the blog post and then insert that into the props of this post component, and then basically render all these posts. So we will receive posts in props.post. So props.post.response, same as in React app. We'll just render each post as a link that links to post ID, and this is how link is done specific link in an Next.js. It uses href, not do, and you have to put a element here and then whatever your actual React logic. And then basically how you do it. And then next SEO is whenever somebody visits this page, it will dynamically update the title, description, and some details when you share it on social media, like the image you will see when you share it on social media and so on. So basically this is the post page, and then the same logic goes for the post page itself. Is basically we prefetch the post and then we pass it in props, and this component doesn't fetch it again. It just needs, because it already had the post in props component, so props.post, as we passed it here, we just need to render the title and the body of the post, and that's pretty much it. So essentially, again, this is CSS in JavaScript. This is basically same as in React, other than how the routing is happening and how we set up all of this logic. But components and inside of these React components that represent a page, the logic, how it's done, pretty much very similar to React, like normal React app, just pretty much all the same, except for this next SEO part that we add. And stuff like that, but pretty much everything is, we don't need to repeat much. Anyways, that's for our next app, Next.js app, and again, that's pretty much all of it. We went over the API, the blog, the dashboard, which is done in React, blog is done in Next.js, API, it's a Node.js API server, done with the Express framework. That's pretty much it. Again, I'm gonna repeat for the 15th time. You don't need to memorize any of this. All the tools you have now and everything I've given you is more than enough for you to officially be like a proper web developer. If you are able to recreate all of these 3 projects yourself after like a month and a half of practicing all of this, and which you can easily do, I'm 100% sure, you can kick off your career as a junior web developer, more actually than a junior. Like I, as a junior, didn't know like 1/3 of all of that I'm just showed you, and all the code bases that I've given you to copy paste and practice with. Like I've had none of this. This is like after my 3 years of learning a bunch of details and so on. And of course, my code bases in reality are in this same kind of structure, but a bit more complex because the projects are bigger and complex. It took time to build all those big code bases. But principle-wise, how I do projects is pretty much very similar to this. And yeah, if you have any questions, feel free to leave a comment or ping me. And that's it. I just encourage you to not get afraid. Go over all the tutorials, however many times you need. Practice, test different things out. Test the combinations of these things. Like if you don't know how to do this, just copy this entire folder. You can download it locally. So if you go to the learning repo, you can just basically go download this as a zip, unzip it, enter these folders through your console, just run npm install or yarn to install all the dependencies for these projects, run them locally for yourself. If you have any issues running them, ping me or leave a comment so I'll see what it's about, because Windows and macOS can have some discrepancies console wise and so on, not 100% the same for some things, so that might be an issue. I always encourage you to Google first to try to solve problem yourself, because that's going to be your daily job. Nobody's going to do your job for you. If you get up to a problem, which I do daily in my work 2 days a day, I invest myself, if I have to, like half an hour or 15 minutes, 5 minutes, depending how annoying the problem is. There's so many answers online for so many different use cases and bugs and issues and things. So you just Google the right thing, very rationally type in the search in Google for your problem you are having, and you try out different examples of the solutions people gave you until you solve your issue, your problem. That's your job. You have to be resourceful and find the answers for the bugs and issues you have in your code. That's pretty much it. I want to tell you one last thing is to have fun. Don't be afraid of all of this. this all again only looks scary when you look at it in one big pile, but when you try to use each tool individually, it's not that hard. Takes some practice, but again, the amount of garbage we have to we had to learn in our elementary school, high school, college, and so on, this is like nothing. But a difference between this and the school we went to, most of us, is this is actually proper skill that you can be very well paid for in the marketplace. And this is it's very cool. Like in a very short amount of time, compare the amount to the amount of time I had to go through just to get to the first job, with all of this like on a silver platter that I've given you in my code you can use. You just need to put some effort to practice, try different things with what the code base already has for you. Just edit stuff, see how it changes in the app, try to go back to the videos. Again, it's important for you to understand how it all connects, how it all works. You don't need to memorize anything. Over time, it's going to get into your muscle memory, and over time, you're going to understand more and more, like easily, how this all works. Like you're going to have a much larger perspective, and that's it. And again, it's going to be a lot of, probably you're going to have, it's going to hurt from a lot of information initially because it's all new things. But over time, you're going to see, okay, I already done this for like 15 times. It's nothing special anymore, you know? So it's gonna, you're just like a React component. Like we already made like 15 React components. The 16th one is not gonna be anything too crazy. You already done it many times. What's the point? Like what, you know, why it's not really that hard after some time. So after this initial learning phase. So yeah, have fun. Let me know if anything, if you need any help, and see you sometimes in the future. Bye.